this video, we learn about one of the instrument is called as XPS, or otherwise is called as ESA. So what is an expansion of XPS? X-ray photoelectron spectroscopy, or otherwise what is ESA? Electron spectroscopy for chemical analysis. So what is XPS? So XPS is that surface characterization technique that can analyze a sample in the depth of 2 to 4 nanometer. So already we know that photoelectric effect. So the Einstein, the scientist, Einstein discovered the photoelectric effect in the year of 1921. So what is photoelectric effect? When it knew that light falls on sensitive material so production of electrons are released. So this is called as photoelectric effect. So due to the generation of production of electron, that electricity is generated. So this is called as the photoelectric effect. Who discovered that one? Einstein discovered the photoelectric effect in the year of 1921. That is sensitive, that is a light, ordinary light, HU, is a falls on the sensitive material that photoelectricity is generated due to the production of electron. So after that year, 1954, the scientist Ty Sigmund discovered that photoelectric effect in the year of 1954. So both are German scientists, and he also got the Nobel Prize. So Einstein discovered the photoelectric effect in the year 1921 and got the Nobel Prize. 1954, Professor Ty Sigmund discovered that photo emission. He also got the Nobel Prize. So both are German scientists. So what he did in Ty Sigmund, so instead of HU, he used the X-ray. So take that one atom, any one of that atom. So center is nucleus. This 1s, 2s, 2p. So to pass that irradiated that X-ray. So X-ray source is irradiated. The innermost electron. This is electron, and here also electron. The innermost electron is ejected out. So this electron is called as photoelectron. So that X-ray source is irradiated and past the innermost electron is ejected out. That electron is called as a photoelectron. So then this electron having the binding energy is greater, having the higher binding energy. So what is the binding energy? The energy required to bind the nucleus with core electron. So here binding energy is very, very high. So more energy is required, more than binding energy. So that's why we are using the X-ray source. So X-ray source is irradiated, that is by passing the innermost electron, core electron is ejected out. That electron is called as a photoelectron. So the high energy source, that is X-ray, is used to eject out the core electron. So core electron having the highest binding energy. What is the binding energy? The nucleus and the electrons are that energy is required to bind the nucleus and the innermost electron, core electron. So that is called as a binding energy. So more energy is required to eject the core electron. So we are not using the outermost electron. So the outermost electron are called as Fermi level electron or valence electron. So valence electron is ejecting is very difficult because it is moving here and there. So that's why targeting the valence electron or outermost electron or Fermi level electron is difficult. So we are using only for core electron. What is a core electron? The innermost electron. So for eject out the innermost electron by using the X-ray source, we are not using the outermost electron or valence electron or Fermi level electrons. So what is the basic principle of this XPS? It is 1s, 2s, 2p, and the kinetic energy, binding energy, so X-ray falls on the innermost electron is eject out, is X-ray, and this is a valence band. And it's a Fermi level, outermost level, and vacuum level, and the electron is eject out. So ejected photoelectron. And this is called as a conduction band. And up to this is called as pi spectrometer. And this is called as pi sample. So there are two pi's are there, pi sample and pi spectrometer. So what is a pi sample? What function? What function due to sample? And pi spectrometer, what function due to spectrometer? So this is a basic principle of XPS. So that the X-ray sources falls on the innermost electron, core electron is eject out. So put that arrow mark like this. So the ejected electrons are called as photoelectrons. So 1s, 2s, 2p, this is a valence band, this is a Fermi level, vacuum level, and this is called as a conduction band. So already you studied in physics what is a valence band and what is a conduction band and what is a band gap. So what is a band gap? The electron move from valence band to conduction band is called as a band gap. That is the energy differences between the valence band and conduction band is called as the band gap. Whether the band gap is very high level means this is valence band and conduction band is the difference is very high means is that called as insulators, and the distance is less means is called as semiconductors. So there is no distance means is called as metallic conductors. So metallic conductors means there is no distance means easily jump the electron from valence band to conduction band. So it's called as the metallic conductors. So electron jumping is very difficult from valence band to conduction band is called as the insulators. So now is coming for that principle of XPS. When that X-ray falls on, the innermost electrons are ejected out. So ejected photoelectron having different kinetic energy, but it is a maximum. So maximum and coming out of the Fermi level and reaches the conduction band. So in order to calculate the kinetic energy of a photoelectron, the following relation is used. So what is the relation to calculate the kinetic energy of photoelectron? So kinetic energy is equal to h mu minus binding energy minus pi spectrometer. So Ke is called as kinetic energy and H is called as a Planck's constant and mu is the frequency of the photon and Be the binding energy and pi spectrometer is already we are studying that there are two pi's are there, pi sample and pi spectrometer. So pi sample one function due to the sample and pi spectrometer one function due to spectrometer. So there are two pi's. So pi means it's one function and pi spectrometer one function due to spectrometer. So this is a basic principle of XPS. So what is that XPS? That is X-ray photoelectron spectroscopy or electron spectroscopy for chemical analysis. So X-ray source is irradiated, so falls on the innermost electron core, electron is ejected out. So we are not using this Fermi level electron or outermost electron or valence electron because the electrons are freely moved here and there. So targeting is very difficult. That's why we are using the core electron. So core electron having the highest binding energy. What is the binding energy? The nucleus and the electrons are bind one another. So the more energy is required, more than binding energy. So that's why we are using the X-ray source is eject out. So you have to calculate the kinetic energy of ejected photoelectron by using this relation. So what is the relation? Kinetic energy is equal to h nu minus binding energy minus pi spectrometer. Another one here we are telling as the Auger electron. So what is Auger electron? So when electron is when the X-ray falls on, that electron is ejected out. That time when vacant is created here. So to fill up the vacant, that higher level electron falls down here. So here also electrons, here also electrons. So the higher level electrons are falls down. But to fill it up that vacant level, that time some energy is released. So that energy is utilized for the kinetic energy and the electron is called as an Auger electron. So what is Auger electron? That one electron is ejected out. That time higher level electrons are falls down. So during that fall of the electron, some amount of minimum, very small amount of energy is released. That minimum energy is utilized for the kinetic energy and that electron is called as an Auger electron. So this is a basic principle of XPS, that is X-ray photoelectron spectroscopy. Now we see for the instrumentation. Instrumentation. So So the first one is called as pre-chamber, and second chamber is called as low vacuum chamber, and the third is called as main chamber. So X-ray source introduces here irradiated one. The sample is coming here, and this is called as the main chamber. And this is called as a rinse. So the photoelectrons are ejected here. So this is called as a photoelectron. So the electrons are then enter into electron multiplier. Then finally it goes into the recorder. It is called as a spectrum. So in this spectrum, we are taking x-axis and y-axis. So x-axis binding energy or kinetic energy versus intensity. So we can get the intense peak when the peak is subtight. And this is called as, the outermost is called as UHV. And this is called as HEA. So that is the instrumentation of XPS. So first one, sources of X-rays, and second one, analyzer, and third one, lens, and fourth one, UHV chamber, and fifth one, channeltron. Channeltron or electron multiplier. So electron multiplier or channeltron. And the sixth one is the recorder. So it is the instrumentation of XPS. So first one, sources of X-rays, that we are using the monochromatic X-ray source, magnesium and aluminium. So that they have the high energy source, monochromatic X-ray source, magnesium and aluminium is used. So that energy of magnesium and aluminium 1253.6 electron volt, and aluminium 1486.6 electron volt. So we are using this X-ray source, magnesium and aluminium, high energy source, that is the energy for magnesium 1253 and aluminium 1486. So next, production of X-rays. So how do you produce the X-rays? When 10 milliampere current is passed, So when 10 milliampere current is supplied, the filament C get heated up and produce electrons. Filament C get heated up and produce electrons. So the electrons are accelerated and bombarded with metallic anode. So the metallic anode is covered by water jacket for cooling. So C is the filament and W is the water jacket. And A is the anode. So this is for production of X-rays. When 10 milliampere current is supplied, the filament C gets heated up and produce the electron. The electrons are accelerated and bombarded with metallic anode. That anode is covered by water jacket for cooling. And next one is it block diagram. So for block diagram, you can get a breech chamber, low vacuum chamber, main chamber. So that sample is introduced into the breech chamber. So the sample is introduced into the breech chamber, is pumped into the low vacuum chamber and pumped into the main chamber. The main chamber is inside the UHV. So what is UHV? Ultra high vacuum. So the main chamber alone is inside the UHV, ultra high vacuum. That pre-chamber, low vacuum chamber, see here. I put one dotted line. So here is only the vacuum environment is maintained. So the main chamber is inside the vacuum environment. So the sample is introduced into the pre-chamber, is pumped into the low vacuum chamber, is pumped into the main chamber. The main chamber is within inside the vacuum environment and X-ray source is irradiated to the main chamber. And that second one is that analyzer. So what is the name of the analyzer? It's a hemispherical electrostatic reflection analyzer. So that analyzer name is hemispherical in shape. So hemispherical electrostatic reflection analyzer. Inside that one, that photoelectrons are generated with different pathways. Take the different pathways, but you have to slow down the movement of electrons. Why you have to slow down the movement of electron? Then only we can get a good resolution, intensity. So the resolution is directly proportional to the intensity of the peak obtained in the spectrum. So that's why we can slow down the movement of electron. For that we have to use that energy. That energy is called as a Pass energy. So what is the Pass energy? To slow down the movement of electron. So that is decelerated the movement of electron. What do you mean by decelerated? That is opposite for accelerated. So the accelerated means it's very high fast. Decelerated means how to slow down. So reduce the rate of that movement of the electron. Why you have to reduce the movement of electron? Then only we can get the intense peak. That is for the resolution is directly proportional to the intensity of the peak obtained in the spectra. So that's why we have to slow down the movement of electron. So for slow down the movement of electron, we are required some amount of energy. So the energy is called as a Pass energy. For decelerating, slow down the photoelectrons. And the next one, lens system. So what is the lens system? Sometimes it's accelerated or decelerated the photoelectrons. For that we are using the two lens. One is the magnetic lens, another one is the electrostatic lens. So apart from that analyzer, the lens also using accelerated or decelerated the movement of photoelectrons. So what is that? There are two lenses are used. One is electrostatic lens, another one is a magnetic lens. So electrostatic lens retard the movement of electron if it is fast moving. Retard means slow down. If it is retard the movement of electron if it is fast moving. And magnetic lens, it focuses the electron which have been slowed down into the analyzers. And the next one is the UHV chamber. So what is the expansion of UHV? Ultra high vacuum chamber. So in this chamber, vacuum environment is maintained to reduce or eliminate the surface contamination of the sample. So it's called as UHV. UHV expansion ultra high vacuum. So the vacuum environment is maintained to reduce or eliminate the surface contamination of the sample. And the next one, electron multiplier or channel trans. So it is a hollow tube. You see here, it is a hollow tube which detect different electron with different kinetic energy. So by applying that electrical potential or by applying that volt, multiply incident electron as a shower of electrons. So the kinetic energy of different electrons are calculated. Already we have discussed how will you calculate the kinetic energy. What is the relation for kinetic energy? So kinetic energy is equal to h nu minus binding energy minus pi spectrometer. This is the relation of calculating the kinetic energy. So kinetic energy is equal to h nu minus binding energy minus pi spectrometer. So this is a hollow tube which detect different electron with different kinetic energy by applying that volt, by applying that electrode potential. So to multiply incident electron as a shower of electrons. And the next one is a recorder. Finally, record the signals as the peaks in the spectra. So that is taken as kinetic energy or binding energy versus intensity. So the position of the peaks gives an idea about take down the dark spectra. So intensity versus kinetic energy or binding energy. With EA, EB, EC, ED. So the EA, EB, EC are specific elements. So in record, it records the signals as a peaks in the spectra, that is taken as kinetic energy or binding energy versus intensity. So the position of the peaks gives an idea about type of the electron present, whether it is a 1s electron, 1s or 2s or 2p electron. So the position of peaks gives an idea about type of electrons are present, and also specify the elements taken for study. And the area of the peaks gives an idea about the concentration of the element under study. So that are for the instrumentation. So instrumentation, sources of X-rays, analyzer, lens system, UHV chamber, channeltron or electron multiplier, and recorder. So the first one is a source of X-rays. We are using a monochromatic X-ray source, either magnesium or aluminium. Both are high energy source. So we are using the high energy source like magnesium and aluminium. And production of X-rays. How the X-rays are produced? That a filament, when 10 milliampere current is applied, the filament C get heated up and electrons are released. It bombarded with metallic anode, is accelerated and bombarded with metallic anode, and the anode is covered with water jacket, is for cooling. And another one is the block diagram. When the sample is introduced into the three chambers are there, chamber 1, chamber 2, chamber 3. The sample is introduced into the pre-chamber, is pumped into the low vacuum chamber, is pumped into the main chamber. The main chamber is inside the UHV chamber, ultra high vacuum. And the next one is an analyzer. So what is an analyzer? Hemispherical, electrostatic deflection analyzer. And here we have to slow down the movement of electron, photoelectron. So the photoelectrons are generated with different pathways, with a different kinetic energy. So that's why you have to slow down that energy, slow down the movement of electron. For that we are using that energy. That energy is called as a fast energy. Slow down or decelerate. So decelerate means slow down. So slow down or decelerate the movement of photoelectrons. And the next one is the lens system. Here the lens are used sometimes accelerated or sometimes decelerated the movement of photoelectrons before it enter into the hemispherical electrostatic analyzer. Before enter into the analyzer, so there are two lenses are used, electrostatic lens or magnetic lens. And the next one is a UHE chamber. So ultra high vacuum, we have to use that high vacuum, ultra high vacuum to eliminate or surface contamination of the sample. And the next one is a channel trap. So by applying the electrode potential, by applying that volt, that incident electron is converted into the shower of electrons. Finally, the electrons are entered into the recorder, that is, we record the peaks as in the spectrum, that is kinetic energy or binding energy versus intensity. And the next one we have discussed about that application. So the application is both advantages and disadvantages. So what are the advantages? To identify the elements, to quantify them at surface level. So first to identify the elements and quantify them at the surface level. And the second one, to analyze the contamination in the surface. So surface contamination can be easily analyzed. Next one, to find the empirical formula of a material. And next to analyze the combined state of the material. And to find the binding energy of the electrons. And to analyze the thickness of the materials. So that are for advantages of the XPS. And another one is the disadvantages. So disadvantages are limitation. It cannot be used for analyzing hydrogen and helium atom. Why it will not analyze hydrogen and helium atom means that atomic number 3 and above only we can analyze. So why you have to take that atomic number 3 and above? So the electrons are used for innermost electron, core electron. So by passing that X-ray source, the core electron, innermost electron is ejected out. So that atomic number 3 and above only can be used. And second one, it can measure up to 10 μm only. It can measure up to 10 μm only, and it is a time consuming process. Time consuming process, no? It is a very slow process and it is a very expensive process. Why we are telling it's a very expensive process means very high vacuum environment is maintained, ultra high vacuum environment is maintained, so it is a very expensive. So that is for that XPS. So all of you clear, I think, what is XPS? So XPS is the X-ray photoelectron spectroscopy. So the other name for XPS, electron spectroscopy for chemical analysis. So for that we are using X-ray source. Further, that 1921 Einstein discovered the photo emission. That is a basic for XPS, photo emission. What is a photoelectric effect? When that ordinary light Hν falls on the sensitive material, photoelectricity is generated by the production of electrons. That discovered that Einstein and got the Nobel Prize in the year 1921. After that, Kai Sigmund, the scientist Professor Kai Sigmund, 1954, discovered the photo emission. Instead of Hν, he used the X-rays. Why he used the X-rays? Because that electrons are emitted. Which electrons are emitted? That innermost electron, core electron are emitted. So Fermi level electron or vacuum level electrons cannot be used. Why we are not using the Fermi level electron or vacuum level? That electrons are moving here and there. So targeting is very difficult. So that's why we are using the core electron or innermost electron. So that X-ray source is used. The core electron having the highest binding energy. What is the binding energy? That energy required to bind that electron and the nucleus. So it binding the electron and nucleus is the highest binding energy. So more energy is required, higher than binding energy. That's why we are using that X-ray source. So by X-ray source is used, the innermost electron, core electron is ejected out. So that is a basic principle for calculating the kinetic energy of various ejected photoelectron. That what is the relation is used? The kinetic energy is equal to Hν minus binding energy minus pi spectrometer. And that is for that basic principle of this XPS, and these are for that instrumentation, sources of X-rays, analyzer, lens system, UHE chamber, channel tron, recorder. I think it is so far we have discussed about that, what are all the advantages and disadvantages. So thank you, please.